Stop trying to debug consciousness. You're not debugging a mind, you are just cleaning up noisy token predictions from a complex, stochastic mechanical system. Most developers treat agent failure as a black box problem, trying to divine why it went off track. This is the metaphysical trap that stalls scaling. The engineering reality is simpler. The agent is a machine whose outputs are influenced by input conditioning, sampling noise, and inherent model variance. Treat it like a high-dimensional physical system. So how do we move from philosophical guesswork to actionable engineering? We must isolate the signal from the noise, and that requires specific mechanical interventions at 3 stages. Stage 1 is the thermal bath, controlling the sampling process. By manipulating temperature and top P schedules, you aren't influencing thought, you are controlling the entropy of the prediction pool. If temperature is too high during the planning phase, you introduce noise. If it's too low, you lock into suboptimal paths. The sequence matters. You need a dynamic schedule. This leads to the dynamic staging approach. High temperature for exploration and divergent thinking, followed by a rapid drop to near zero when committing to the execution path. But even perfect prompting suffers from garbage in, garbage out. The first intervention must be the input conditioning buffer. This buffer doesn't just hold context, it cleanses it. It identifies prompt drift, filters out low-signal tokens from upstream systems, and ensures the LLM receives a maximally coherent prompt. Think of it as the agent's cognitive cleanse. It's a necessary engineering layer that protects the model from the entropy of the real world. The final stage is the output validation loop. Don't trust the agent's output, treat it as a hypothesis that must be tested against reality. If you're asking an LLM to perform a task that requires strict JSON output, but the prompt was ambiguous, it will hallucinate structure. Your job is to enforce the contract. This is where you build the post-processing critic model, a smaller, faster LLM whose sole job is schema compliance checking and error categorization. If the critic flags a failure, you don't restart the agent. You use the error report to inject targeted corrections into the *next prompts context window. This transforms the system from a one-shot attempt into a closed-loop, self-correcting machine. This is the architecture of reliability. The biggest shift is this: you are no longer trying to debug the thought. You are tuning the physical parameters of the machine, the filters, the temperature knobs, and the validation gates. If you move past the metaphysical view and adopt this mechanical engineering mindset, scaling your autonomous agents becomes a solvable problem of fluid dynamics and control theory.